Okay, today we're going to look at Module 3, which is binomial probabilities and Poisson probabilities and probability distributions as a whole. So the first lesson, we're going to look at how to find the mean, the variance, and the standard deviation of a binomial distribution. Now, what looks a little different, they kind of look like frequency tables, but what's a little bit different is the fact that instead of having a frequency for each value, you have a probability for each value. So therefore, you have the entire data set because some of your probabilities will equal 1 if it's a true probability distribution. So that's why we're using sigma here instead of S sub x, because now you're not going to see S sub x, which is a sample standard deviation, in the calculator when you do this. Okay? So what we're going to do first, I'm going to try to zoom in on the calculator so you can see this. Let's see if I can do this without a glare. Okay, we're going to push stat, and we're going to edit. Okay, and then in list, I'm going to clear out what I've got here. Okay, in list 1, we're going to put the 0 through 5. Let me do it for you, and then I'll put it back up there. Okay, so I've got 0, there. Okay, 0 through 5 in list 1. And then in list 2, we're going to put our probabilities. So the first one for 0 is 0.001, and then 0.015, 0.088, 0.264, 0.396, and for 5 it was 0.237. Now, like I said, the sum of your probabilities should equal to 1 or very, very close to 1. It could be a little bit off due to rounding issues, but this is the table that we're given. Now, to calculate the mean, variance, all that data, kind of like we did in chapter 1 through 3, it's very similar to how you would calculate the mean, variance, and standard deviation for a weighted mean. Okay, so what we're going to do is we're going to clear this out, and we're going to do a stat, go over to calculate, and we're going to do one variable statistics. But instead of just pushing enter, since you have two ones, just like when we did the mean of the weighted mean, you use second L1, comma, second L2. And then you hit enter. And then this gives you all the information. Notice again, your S sub x is missing because we're not doing a sample, we're looking at the entire population. So you will not see that when you're doing a probability distribution. So it gets us our answers that we need. Okay, in our case, we have that the variance, let's start with the mean. The mean would be 3.748. The standard deviation is 0.969. And the variance, again, is the standard deviation squared. So you would do 0.969 squared. And keep in mind, when you're doing this stuff on my math lab, they may want you to use all of the digits. So instead of just using 0.969, they may want you to use the entire thing you see for sigma sub x on your calculator, not just three decimal places. So just be careful. But if we do the 3, we get 0.939 as our variance. Now you can also do the mean, the variance, and standard deviation of a binomial distribution. That's kind of where we're heading in this particular chapter. So we're going to look at that. Now, with a binomial distribution, you have formulas for this, and these will all be on your formula sheet. The first one, to find the mean, is n times p, and I'm going to talk about what all these letters mean. To find the standard deviation, it's the square root of n times p times q, and to find the variance, it's just n times p times q, i.e. what's under the square root. So this is what we're given for this example. We're given n is 50 and p is 0.2. Now n, for everything we do in statistics, stands for your sample size. P is your probability of what we call success. Okay? Q is your probability of failure. They will give you probability of success in all these types of problems. How do you find probability of failure? Well, all you do is you take Q is 1 minus P. Okay, so if I want to find Q, I'm going to do 1 minus 0.2, which is 0.8. Okay, so that's my Q when I get to the point where I need it. So the first one, all I do is 50 times 0.2, which is 10. Okay, so my mean of this particular binomial distribution, and by the way, how do we know it's binomial? Well, there are characteristics that you want to look at. There's really 4 things that need to be true for a binomial distribution, and you go back and look in your notes in order to figure that out. For this particular example, I'm just telling you up front that it is binomial. Okay, then we're going to do the standard deviation. So it's the square root. Now be careful, because when you type this in your calculator automatically puts a parenthesis there. So don't use parentheses to symbolize the multiplication. And then you're going to do 50 times 0.2 times 0.8. Then close your parenthesis, or you will get the wrong answer. Alright, when I do that, I'm going to do square root of 50 times 0.2 times 0.8, and I get that my standard deviation is 2.828. Now, when you're going to do the variance, don't just take that and square it. Technically, even though that's correct, because we rounded, you're going to be a little bit off. It's better just to do what's underneath the square root. So again, I'm just going to do 50 times 0.2 times 0.8. And I'm going to get 8. Okay? So that's the difference between a probability distribution and a binomial distribution. For binomial, you have distinct formulas you're going to follow. For a probability distribution, you just use the calculator.